Welcome to this explainer where we break down complex topics into clear, understandable pieces. Today, we're tackling something you probably use every single day. How does your phone or any computer actually recognize your face? Let's get into it. You know that moment you pick up your phone, glance at it, and it just unlocks? It feels like straight up magic. But it's not magic. It's an incredible field of technology called computer vision. And today, we're going to pull back the curtain and see exactly how the trick is done. Now, this whole breakdown comes to you from Anderson, who's a huge enthusiast in industrial automation. It's inspired by the amazing work in the textbook, Computer Vision, Algorithms and Applications. We aren't affiliated with the author, but we're massive fans of the work. So think of this as our deep dive, inspired by the best in the field. Okay, first things first, we need to get our heads around a really fundamental idea. The way we see the world and the way a computer sees it are two completely different things. It's not even close. So when you look at a friend's face, your brain instantly recognizes them. You see eyes, a nose, maybe a smile. You see a person. A computer, it sees a giant spreadsheet. Seriously, it just gets a massive grid of numbers from its camera. Each number just describes one tiny dot, one pixel, and how bright or colorful it is. No face, no person, just data. And that right there is the entire goal of computer vision. It's this huge challenge of teaching a machine how to look at that giant grid of numbers and actually understand what it's looking at. To find a face in the data, just like our brains do with the light that hits our eyes. So facial recognition isn't just one single aha moment for the computer. It's actually a super methodical three-step process. First, the computer has to find a face in the picture at all. That's step one, detection. Then, and this is the really cool part, it analyzes that face and turns it into a unique code, a sort of mathematical fingerprint. That's feature extraction. And finally, it compares that fingerprint to a database of faces it already knows to find a match. So let's zoom in on that second step, because it's where the real magic happens. So, how on earth does a computer create that unique signature for a face? Well, over the years, there have been two main ways of thinking about how to solve this puzzle. I mean, think about it for a second. The problem is so tricky. How do you take something as complex and unique as a human face and boil it down to a simple, consistent code? Well, the first big breakthrough came from what we call a classical approach, where some very clever scientists basically wrote the rule book for the computer. One of the most famous of these classical methods is called eigenfaces. It sounds complicated, but the core idea is brilliant. Researchers took thousands of photos of faces and used a statistical method to find the most common patterns, the most important ways that faces differ from each other. This gave them a set of ghostly, generic faces, kind of like the ones you see here. Think of them as the basic ingredients for any human face. Exactly. The best way to think about it is like a recipe. Your specific face can be perfectly recreated just by mixing these basic eigenfaces together in different amounts. You know, a little bit of this one, a lot of that one, maybe none of another. And that unique combination, that specific recipe, becomes your face's digital signature. Pretty clever, right? But that whole approach of humans designing the features, well, it has its limits. The next big revolution, the one we're living in now, came when we stopped giving the machine a recipe and instead taught it how to figure out the recipe all by itself. This was the deep learning leap. Yeah, around 2012, everything just changed. Suddenly, we had these massive datasets of images and computers that were way more powerful. This let a whole new approach take over: deep neural networks. It's basically the difference between handing the computer a blueprint and giving it a brain so it can learn to draw its own. So here's the real kicker. In the old way, a human expert would have to program the computer, telling it, hey, look for the distance between the eyes, or measure the shape of the nose. With deep learning, you don't tell it anything. You just show it millions and millions of faces with names attached, and the network itself figures out the most important patterns for telling people apart. And these patterns are often way too complex for any human to even describe. It does this using something called a convolutional neural network, or a CNN. Just picture an image passing through a whole bunch of layers. The first, early layers learn to spot really simple things, like basic edges, corners, and color gradients. Then, the next layers take those simple shapes and learn to combine them into more complex stuff, like an eye or a nose. Deeper and deeper it goes, assembling those parts into whole faces, until the final layers can identify a specific person. It literally learns how to see, all on its own. So let's just pause for a second. We've gone on this journey all the way from a simple grid of numbers to a confirmed identity. And along the way, we've seen the technology itself evolve, from human-designed rules to a kind of machine-learned intuition. It's pretty amazing. But even in this wild new age of AI, it's so important not to forget the fundamentals. And this quote from researcher Sri Nair, it just nails it. When these super complex systems don't work right, the only way to figure out why is to go back to those first principles, to really understand what the computer is seeing. And that brings us to the really big question, doesn't it? The technology is unbelievably powerful, and it's getting better all the time. Understanding how it works is one thing, but the next, and maybe even more important conversation, is about what we as a society decide to do with it. Hey, if you enjoyed this deep dive, please do subscribe to the channel. It really helps us make more content like this. And definitely leave your thoughts and questions in the comments. We'd absolutely love to hear from you. And stick around, because we're going to be tackling some even more advanced topics very soon. And as a final note, this entire explainer was built on the incredible and foundational work found in Richard Salisky's textbook, Computer Vision, Algorithms and Applications. Thanks so much for tuning in.